really be the speaker, the official speaker, but I've chosen to defer to something far more important because we have an opportunity to have one of the world experts on a topic of molecular hydrogen, which is one of the most recent and remarkable discoveries in therapeutic nutraceuticals. So I just thought it's such a rare combination, and any of you who came for any questions about water, drinking water, quality of water, water chemistry, or minerals and trace elements, etc., you are welcome to come back to my booth at any time during the show and have a private tour of any of your questions. So Tyler has studied molecular hydrogen. He's actually, I have to say, world-renowned now, of the small group of people who are experts in this. He studied with the discoverers of molecular hydrogen in Japan. And we have only one issue. He's going to have to move very quickly because immediately after this, he is going to the airport and flying to Tokyo to deliver more talks, okay? So I'm going to turn it over to him immediately, and if we get tied for questions and answers, I will do the best I can to answer them at the end. Take it away.
All right, well, thank you. So, molecular hydrogen. Because this is AutismOne, my talk is geared towards potential clinical applications of molecular hydrogen medicine for autism. Now, as Robert mentioned, the IAD in the field of molecular hydrogen is emerging very rapidly. There is countless reports and case studies of people receiving really remarkable benefits from hydrogen. And in order to understand this, first we ask the question of what is molecular hydrogen? What are we talking about? And effectively, this is the molecular hydrogen. It's two atoms of hydrogen combined together. This is the gas. People can think of like the Hindenburg. This is the same gas. It's very explosive. That's because it's energy dense. In fact, hydrogen is 3 times more energy dense than gasoline. And for a long time, we looked at hydrogen for alternative fuel source. Well, now we're seeing that hydrogen actually is good for therapy as well. So to come some background of molecular hydrogen, we've seen it's therapeutic in over 150, actually closer to 170 different human and animal disease models and essentially every organ of the human body. This is what the scientific research is suggesting. And in fact, the research is growing exponentially. You can see since 2007, it's really growing and published in very high respected journals in the science industry. And also here in the U.S., this is some of the organizations that have been involved in some of the hydrogen research as researchers or collaborators here in the U.S. as well. It's not only being done in Asia, but that is where most of the research is taking place at. This is an interesting review from Loma Linda University. They found that hydrogen had a remarked therapeutic potential to help with the top 8 of the 10 disease-causing fatalities as listed by the CDC in one of their review articles. This was even a few years ago, and the more research has shown this to truly be the case. So the question that we have then is, how does hydrogen exert these biological effects in, like I said, essentially every organ of the human body? Well, one of those things we've seen is hydrogen can act as an antioxidant. It can neutralize the toxic hydroxyl radicals. This was a publication in 2007 by Dr. Shiego Ota that really spawned the research of hydrogen. This is very critical that we follow this. We're going to talk about this in a little bit more. First, to understand the importance of the antioxidant, we need to understand the free radicals, reactive oxygen species. These are just a few of them. We produce them all the time, and they are effectively linked to all the various disease pathologies. They can damage DNA, RNA, proteins, cell membranes. So many of these diseases can indeed be linked to oxidative damage. Well, same with autism. Oxidative stress has also been linked to causing as a causative factor in autism as well. Now, these free radicals are generated primarily within the mitochondria at the various electron transport complexes, and these free radicals happen all the time. Right now, how many of us are breathing? Well, right now you are generating free radicals. So, you know, the best thing to do right now is to hold your breath. Of course, if you did that, you would not live very long. So oxygen, of course, is vital to our life, essential for our life, but we do end up producing these free radicals. And I'm going to talk to you a little bit about, actually not all free radicals are bad for you. Some of them are actually good. And another reason why molecular hydrogen is a superior antioxidant. Importantly, though, because these free radicals are generated and they're continuously assaulting our body, in order for us to live, our body has to have a way to protect ourselves. So the body actually has its own endogenous antioxidants. So you have things like glutathione. Many of us have heard of glutathione before, or superoxide dismutase, catalase, right? These are enzymes or antioxidants that the body makes to help protect us against these free radicals. And those are very important. And then they're very regulated. And this is a very important graph here. Life is balanced really between this oxidation and reduction. And you can think of it just like anything out there. We have, like a battery, for example. You have a negative and a positive terminal. You can't just have the positive side, like just the oxidation side, right? You have to have the other side as well, or else the battery's not going to work. And that's also true with the cells, with the organs, the tissues. Everything is balanced. And on this teeter-totter I kind of have here, we have on the one side oxidation, various oxidizing molecules. And on the other side we have the reducing molecules. And the things that characterize these two molecules the most is, on the one hand, oxygen for oxidation and hydrogen for reduction. These two molecules of life can then react together to form the life-giving solvent water. So it's a rather romantic story of this relationship between hydrogen. Hydrogen truly is the father of all the elements, number one on the periodic table, and is what balances this whole relationship. We've been focusing about oxygen for so many years. How many of us heard of, oxygen bars, hyperbaric oxygen, oxygen water, breathe more, meditate and breathe, all this oxygen stuff? Well, now we're starting to understand that we need a balance. And this balance comes from getting back to the roots, the primordial antioxidant, so to speak. This is hydrogen. And as we talked about our endogenous antioxidants, well, what we see also is aging and certain diseases and even toxins can actually lower our body's own antioxidant self-defense system, making us more suspect to diseases or toxins or different things because we have lower glutathione levels. Well, importantly, as I mentioned, not all free radicals are bad. That's maybe a contradictory statement, as we have heard that free radicals are the cause of aging, the cause of disease, the cause of so many different things since the 1930s, called the free radical theory of aging. Well, it turns out that yes, free radicals can be bad, but they are not always bad. Indeed, some of these free radicals are important molecules for signal transduction, for immunity. Our immune system creates free radicals to kill the bacteria, for vasodilation. We have things, how many have heard of like nitric oxide, right? Won a Nobel Prize. That's a very big thing right now. Nitric oxide is a free radical. That's how many of the things, nitroglycerin, that's how that works. Viagra, that works to increase nitric oxide. We don't want to neutralize this important molecule, but it is a free radical. So free radicals are very important. Some of them are very, very damaging. Others are still very important. But everything needs to be regulated because, like I said, like a battery, there is a balance. There has to have this homeostasis, okay? And this is very interesting. Perhaps this is why many of the clinical trials with supplemental antioxidants often have deleterious effects. When you go into the research and you look at these studies where they've taken high doses of very synthetic antioxidants, they've had to stop the studies. Like not even halfway done, because the people taking the antioxidants were dying, getting cancer, lung cancer, prostate cancer, faster than those on placebo. One of the reasons that has been suggested is perhaps these antioxidants are potentially scavenging and neutralizing too many of these beneficial molecules that are so important for us. And in fact, when we exercise, we breathe more. At least I do. When I go run, I breathe more, right? So by default, you will be producing more free radicals. But it turns out those free radicals are important signaling molecules to induce various adaptations so that you can run farther and harder and longer next time. And actually, they've done some studies where taking high doses of antioxidants could actually negate those benefits of exercise training, because you don't have those free radicals to activate the transcription factors necessary to induce things like mitochondrial biogenesis. Now, this is what I'm saying right here, and here's one of the studies. May actually negate. This is a review of many of the studies that have been done. So your question then, okay, well, Mr. Tyler, LeBaron, you're saying all these negative things about antioxidants or whatnot, but how does hydrogen any different if we're saying hydrogen is an antioxidant? Well, first, let me be clear. I'm not saying antioxidants are totally just negative and bad. I just want to illustrate the importance of redox homeostasis, okay? It's not just about free radicals. It's not just about antioxidants. Maintaining that redox homeostasis, and that is what makes H2 different. First off is hydrogen is a selective antioxidant. That title there, Nature Medicine, you can read that important word. It selectively reduces the cyto or cell cytotoxic oxygen radicals, such as this hydroxyl radical, OH neutral. This is one of the most damaging lethal radicals that is produced in the body. It does not have really any benefit other than it just damages your DNA. And hydrogen can selectively neutralize that molecule. And you see the equation, the stoichiometry here, is one molecule of hydrogen will react with two of those hydroxyl radicals, converting them to water, because hydrogen plus oxygen is water. That's a very neat thing in and of itself, is just the fact that there's no toxic byproduct. All the other antioxidants, if you have vitamin C or anything, if they donate their electrons, well, now vitamin C doesn't have electrons anymore. So it's considered a pro-oxidant. So the body has to quickly rejuvenate that, metabolize it. It has to do something, or else it can catalyze further damage or do something. The body has to take care of that, clear it from the system, from the cells. Versus with hydrogen, it just converts it to water. It's a very simple reaction. And there's some other reasons why hydrogen is superior, because of its rapid diffusion. Hydrogen has the highest diffusivity of all gases and really anything else. So it's able to penetrate quickly throughout the entire body. When we look at the cell membrane, it's difficult to get inside of the cell membrane, and things that get inside the cell easiest is, number one, the size. The smaller it is, the easier it can get inside. Well, what is smaller than hydrogen? Nothing. It is the smallest molecule. The other thing is whether it's neutral, hydrophilic or hydrophobic. Well, hydrophobic things can get into the cell membrane easier. They don't require things like ion channels or specific transporters. So molecular hydrogen as a gas can quickly diffuse through the subcellular compartments, through the cell membranes, into the mitochondria, the nucleus, very easily. And this is what this graph is illustrating. That red little exploding thing, those are hydroxyl radicals. We see those happening in the nucleus, in the mitochondria, in different locations. That's where the damage is occurring. Well, we have the blue diamonds. Those are hydrophobic antioxidants, like, say, vitamin E. Those don't mix in water very well, so they're going to stay in the cell membrane. Has a difficult time for those types of antioxidants to actually get to the mitochondria or nucleus, because they're hydrophobic. They're not water soluble, so stay in the membrane. But see, the damage, a lot of the damage is really occurring inside of the nucleus and the mitochondria. Then you have things like the hydrophilic antioxidants, which is the other shape. Those are like vitamin C that are water soluble. Well, now those have a difficulty getting inside of the cell through the cell membrane, because the cell membrane is hydrophobic. So it has to go through specific transporters, the whole process. But again, because of hydrogen's superior distribution properties, it's able to rapidly and quickly penetrate through the cell membrane and enter to the nucleus, mitochondria, and everywhere else. Additionally, we see that hydrogen does indeed reduce the oxidative stress. These are just various markers of oxidative stress, the MDA or T-bars, 8-HDG, which is a marker of DNA damage. All of these different things are markers of damage, of oxidative damage that occurs where hydrogen has been shown to actually decrease that oxidative stress. And on the other side, we see markers of antioxidant status, such as the superoxide dismutase, glutathione, catalase. Administration of hydrogen can actually increase the body's antioxidant status as well. So we clearly see in animal and human studies that indeed molecular hydrogen is able to have these beneficial effects. Now, I'm going to explain 3 simple reasons as to why hydrogen is able to easily and simply offer this protection against oxidative damage. One of them, as we already talked about, H2 may scavenge these hydroxyl radicals as suggested by this article here. Another one is hydrogen can actually activate what's called the NRF2 pathway, and that leads to an increased production of our body's own antioxidants. So the glutathione, superoxide dismutase, catalase, all those different systems, molecular hydrogen is able to upregulate our body's own natural sources. That's very powerful. Think about that. You take the hydrogen, it goes through the brain or other locations or a specific cell, and there is able to increase your glutathione levels or your superoxide dismutase levels. A third reason is hydrogen in some cases can actually prevent ROS formation via cell modulation. I have reference studies on the side there. In this case, you have something like the NADPH oxidase system. This system can take your normal molecular oxygen and turn it into a free radical called superoxide. See the activated side right there, so it's O2 minus. So now you're forming these free radicals. Well, administration of molecular hydrogen can actually downregulate this system to actually prevent this superoxide radical from forming in the first place. So this has a prevention attribute as well, and not just for the treatment. It hits all the areas in all the right ways. Now, so I explained that hydrogen has all these effects in so many different disease models, in all these organs, and the question has been why or how is it actually working? One of those was through this antioxidant mechanism, but still, even with its antioxidant mechanism, as amazing as it is, that still may not actually fully answer why H2 has so many benefits. And in fact, it has been suggested that H2 may actually act as a signaling molecule, because under the right conditions, hydrogen has been shown to alter the levels of over 200 different biomolecules. So when we look at other gaseous transmitters such as nitric oxide, carbon monoxide, hydrogen sulfide, these different gases, hydrogen gas has been suggested to potentially be this 4th gaseous signaling molecule, which is responsible for many of the therapeutic benefits in addition to its antioxidant activities. Now, let's look at some of the studies so you can see about some of the superiority of hydrogen compared to other antioxidants. In this one here, what we have is a long-term treatment of hydrogen-rich saline and with oxidative stress induced by nicotine, and this is in an animal model. But these graphs are excellent at showing the superiority of hydrogen. On your far left, you see the first graph, and there's T. T stands for, Tyler, stands for testosterone. And what we see is when we don't give anything bad, no nicotine, no hydrogen, that's the black bar, that's normal. That's the white bar, that's normal, that's when everything is just the same. But then when you give the nicotine, you see it brings that testosterone down very low. It plummets it. And it even gets a star because it was statistically significant, okay? Now when you administered molecular hydrogen with the nicotine, you see what happened? It kept it back to that homeostasis. It prevented the decrease. Now, when you tried things like vitamin C and vitamin E, it really didn't work. And the same is also true with the other graphs, sperm motility and sperm concentration. Only the molecular hydrogen was really effective in these areas compared to vitamin C and vitamin E. Here's another very powerful graph, and it illustrates 2 principles. The first is obvious, that hydrogen is useful for radiation protection. In fact, NASA has been doing some research to use hydrogen-rich water, for example, to protect their astronauts during space travel. But I want to point out one other thing that may be missed, and that is this graph the first bar you see, that's when nothing was administered. The y-axis, okay, that's a marker of DNA. It says concentration of OHDG. That's a marker of DNA damage. And you notice that there's some DNA damage that occurs all the time. There are basal levels of DNA damage, of oxidative stress or oxidation occurring in your body at all times, as we talked about, right, this balance. Now, when you administer the hydrogen with no radiation either, notice what happened. That's right, nothing. It stayed the same. So the hydrogen didn't reduce oxidative stress even less than it normally should be. It kept it right there at the normal levels. Then when you administered the radiation, you see that the DNA damage went way up, as would be expected. And then the next graph, the last one, the bar, when you administer the radiation with the hydrogen, you will note that the hydrogen attenuated quite significantly the damage done to the DNA via the radiation. So that illustrates two things, as I said. One, that hydrogen is helpful in mitigating the damage of the DNA from radiation. And secondly, hydrogen is very good at maintaining homeostasis. It doesn't perturb our normal redox homeostasis. Here's another very powerful article I want you to consider. Maternal molecular hydrogen administration ameliorates rat fetal hippocampal damage caused by uteroischemia reperfusion. Now, when mothers have their child, and there can be complications during birth. And sometimes that complication leads to their child having a lack of oxygen, a hypoxic condition, ischemic reperfusion injury can result, and that can lead to damage to the brain, to degeneration of the brain cells. In this study, what they did is they had the mother drink hydrogen-rich water. They couldn't really have the baby because it's like inside of this, kind of difficult to do. So they had the mother drink hydrogen-rich water. Because hydrogen is so small, it can just diffuse right through the placenta very easily. The mother drank the hydrogen-rich water, and you see the sham, that's the control. The mother in this case didn't drink hydrogen water, didn't do anything, just had a perfect delivery, and we see on the x-axis degenerated cells, that's normal. There was hardly anything that happened. The black graph with the IR, ischemic reperfusion injury, that one, the mother did not drink the hydrogen water, and there was an IR injury, and we see the degenerated cells was very high. In the next group, the mothers drank hydrogen-rich water. The injury still occurred, but you will note that the degenerated cells was almost like it never happened. That's a powerful study. Here's another one that's very interesting. Mitochondrial dysfunction in autism spectrum disorders. A systemic review meta-analysis. This is a very powerful article showing that the autism, one of the etiologies or problems with it is mitochondrial dysfunction. So is it possible that hydrogen may also benefit the mitochondria and perhaps then also benefit autism? Well, the mitochondria is a very important organelle of the cell. It is the energy-producing organelle, it is the powerhouse of the cell, right? It produces the ATP, the adenosine triphosphate. That's what the energy currency is. And an average person, they need about the same amount of ATP that they weigh. So if you're 150 pounds, you need to resynthesize about 150 pounds of ATP per day. That's done via the mitochondria. That's a big task for the mitochondria. Okay? Now, H2 actually can stimulate the mitochondrial function. Here's the various aspects of the mitochondria. We have different complexes, the electron transport chain, and indeed, hydrogen is able to stimulate the complex 1, 2, 3, 4, and 5, as well as the ATP synthase enzyme, which actually leads to a higher ATP production. So it's very good for athletes in different areas as well. On another note, when we look at toxins from the environment, pesticides and different things, this may also be a causative factor in autism, is toxins we get from the environment, right? Well, maybe pesticides or organophosphates have a causal link to the development of autism as well. Well, will hydrogen have any benefit in that? Maybe. In this article here, this is what this suggests. Oral intake of hydrogen-rich water ameliorated chlorophyrus-induced neurotoxicity in rats. This is an organophosphate. It's a pesticide, right? And in this study, it showed that the drinking of hydrogen-rich water was able to decrease the damage done by this, the neurotoxicity done by this pesticide. Here's another very interesting one. Okay, so we talk about the brain. Why is it so difficult to treat many of the neurological conditions? Because the blood-brain barrier prevents hydrogen from going through. Well, hydrogen can easily go through the blood-brain barrier. The other thing is that if the blood-brain barrier gets damaged, that allows other toxins or different things to enter into the brain, further exacerbating the problem. Well, in this article, this was showing that hydrogen can actually attenuate some of the damage to the blood-brain barrier. And they found that the drinking of hydrogen-rich water improved the neurological function. This is an animal model, and via a number of its reduction pathways and some cell signaling. This is an interesting one as well. This is a double-blinded clinical trial in Parkinson's disease. So these are not studies that are only done in animals or in cells. There are human studies as well. And this is just over a year-long double-blinded clinical trial in Parkinson's disease, and they showed that drinking of hydrogen-rich water had a significant therapeutic effect in attenuating the Parkinson's disease score. And this is an interesting, this is another thing to think about. Ghrelin. How many of you have heard of ghrelin before, right? The hunger hormone. Now, this is a very, very powerful hormone. It's very interesting that the autistic children often have altered levels of ghrelin than, less than they should. Well, I don't know if any of you looked at some of the research of like fasting and intermittent fasting in this area, but it's a very growing body of research, and it's one of the reasons for the benefits is possibly because we fast, we increase more ghrelin, and that ghrelin in turn is very neuroprotective. And actually, there's this other article, ghrelin is a promising therapeutic target for co-occurring autism and epilepsy. Administration of ghrelin. Wouldn't it be neat if you could take something that's natural, that like fasting could increase ghrelin without taking a synthetic drug? Well, look at this. This is very interesting. Oral hydrogen water induces neuroprotective ghrelin secretion. This is done in mice. But you see the power of hydrogen. It's very interesting. It's able to have all these neuroprotective effects as an antioxidant, the cell modulation properties, but again, it's able to activate various second messenger systems like gastric ghrelin release, which in turn gives other neuroprotective benefits. This is another interesting one, physical exercise and intermittent administration of lactulose. Lactulose is a fiber, and it's metabolized by the intestinal flora, and it produces hydrogen gas. Of lactulose may improve autism symptoms through hydrogen production. As we exercise and we eat a healthy diet, guess what? We produce more hydrogen. And we can also simply ingest additional hydrogen through other methods. Lastly, hydrogen has a very high safety profile. There are hundreds of studies that have shown its therapeutic benefits, but effectively those studies have also showed its high safety profile. Furthermore, hydrogen has been used in deep sea diving since the 1940s to prevent the bends, or decompression sickness. So it has a very good track record of being safe at literally thousands, if not millions of times higher concentrations than what we're talking about for therapeutic use. Additionally, as mentioned, intestinal bacteria can metabolize various fibers to produce hydrogen gas, once again suggesting how natural the hydrogen is to our bodies, how safe it is for our bodies. So all of these things show its high safety profile, and with all the studies we just reviewed, we didn't go through all 600 of them, but you can clearly see this is something that needs to be looked at seriously. More research needs to be done so we can understand the correct dosing and what disease pathologies it works best for and how to use it. But because it has such a high safety profile, it is indeed something that should be seriously looked at and tried. Many people have reported remarkable benefits from using hydrogen. So you ask, well, how come hydrogen is not here right now? How come I don't know about it if all this stuff is so good? Well, it's a new research. I mean, generally the marker is about 10 years behind the science. And because the science is really shown in 2007 in the Nature Medicine publication, it takes about 10 years. And my prediction has been for the past few years that in the year 2017 will be the year that marks the ubiquitous awareness of its exponential growth. In other words, if you look at the exponential growth chart, 2017 will mark the year where hydrogen, the awareness grows exponentially. And then probably 2027 will be, everyone will know about hydrogen by that year. So, for that's my presentation. I hope that you will look into this. This is my website. Again, I'm from the science-based nonprofit Molecular Hydrogen Foundation. There's the contact information right there, molecularhydrogenfoundation.org. I hope you will join the hydrogen revolution and go online and learn about hydrogen.